He's a Global Technical and Business Development Manager at SGS. And he's going to be talking to us about electrical transformer oil. It's a primer on the analysis and diagnosis. So this is a recorded video, but Mike is available to take questions at the end of the presentation. So here we go. Enjoy.
Hello, today's discussion is going to be on electrical transformer oil. Basically a primer on the analysis and even the diagnosis. We'll touch a little bit into sampling as well. My name is Mike Holloway with SGS, Oil Condition Monitoring. Now, there's a lot of value in transformer oil testing for sure. These things are pretty hefty assets. The bottom line is that these asset managers have to go about determining the reliability and overall failure opportunities that many of their assets have to offer, and these are considered some of the most valuable assets. An early detection warning system is vital in these things. If there's a short or trip that occurs, you could have a power outage, and that could last for a period of time. That would be very, very unfortunate. Now, prevention is key. If we can get on top of this before a catastrophe happens, we can avert some very costly mistakes. Routine oil analysis can help us get there. It's been proven time and again that oil analysis is always far cheaper than the failure that results without doing oil analysis. A couple different things we're going to explore. Test slates, the analysis, the appropriate testing that's actually carried out. There's a whole number of different tests that we can actually perform. There's some routine tests that should perform every month or every 6 months, and there's some more specified tests as well. Something else we want to touch upon is sampling. Now, we won't go into too much detail on sampling because it is rather thorough. However, though, we do have to consider certain aspects, which we'll talk about a little bit later on. It's all about a representative sample, keeping it clean and being safe. And then finally, the diagnosis. Analysis means nothing if you can't diagnose it properly. And that's what we're here to do, here to help out. By doing this, we can also set up some alarm limits. Now, oil is a vital part of the transformer. It's going to serve several different purposes. It's going to act like an insulator as well as a coolant. In some cases, it actually protects metal componentry inside. The problem is, though, it can be stressed. It can be stressed both electrically, mechanically, and chemically. Any other way, that can bring down the oil into a whole other level of not necessarily being a reliable partner for us. Now, what we can do is do some quick and accurate testing to basically understand, essentially avoid any excessive or unnecessary maintenance that could be occurring. Within this, there's a guide. The IEEE has actually put together a diagnostic field guide for us. We use it, and I think actually it's probably not a bad idea for everyone to get their hands on as well. There's some common practices that are actually discussed in these things. But once again, we're going to be looking at various types of procedures and practice diagnostic methods for the windings and the bushings and the field and the tap changers and tanks and so forth. We're going to go look into the various test interpretation of the data that's derived as well. The ASTM has put together a very thorough list of the kinds of tests that we want to be able to carry out according to a certain procedural methodology. Also, test frequency. That's going to be a vital part. We can help you out with that as well. This guide, it actually suggests different types of frequency of testing. It depends upon the unit type, the size, the age, and even operating history. Establishing a maintenance schedule based on these conditions is going to be essential for you. One thing we want to do is do in-service oil screening. With that, we take a look at a whole host of different types of analysis, from the acid testing, color, all the way down to flash point. I'll take a little bit of time here in a bit and describe why these things are essential. Also, contamination testing, things that we can look at in terms of going even deeper dive. Different types of contaminants that actually can establish themselves and enter into the system and actually create all kinds of havoc. Here are the physical properties. First and foremost is visual examination. You can tell a lot by what the oil looks like. It indicates maybe an absence or the presence of some undesirables as well. We're also going to take a look at the aniline point. Now, the aniline point is essentially always considered the solvency of that oil, and it may be actually related to some sort of gassing or impulse characteristics going on in the oil itself. We're going to take a look at the color. Obviously, as oil darkens, it's a great indication that it's beginning to oxidize. Well, oxidation is not necessarily a very good thing for oil at all, so we want to be able to take a look at that, and color can help us understand it. And then this flash point. That's going to help us understand the safe operating conditions of these things. Sometimes flash points affected by contamination. That's something that we also want to take into consideration. And then we get into interfacial tension. Now in this, we'll take a look at the values and consider that, say, for instance, a high value. That could mean that there's some undesirable polar contaminants in there. And so we're actually going to mix the oil that we're going to look to test, as well as, say, water. We're going to understand if the phase separation and the interfacial tensile forces that can actually be measured. Now, if there's a high concentration of polar additives that are found in there, that are polar contaminants, I should say, that's going to change the interfacial tension, and that can be registered. That's going to give us a great understanding, because remember, water is also polar. And then pour point. Pour point's essential to understand too. Keep in mind, a lot of times this oil is actually helping lubricate a lot of the moving parts within these componentry too. So if you have a higher pour point, it's going to tend to thicken up. That's not a very good thing either, because then that could actually, in a way, freeze up the mechanical devices found within. So we're going to want to make sure we have a low pour point. And then the relative density. The relative density is actually a really important factor as well, because it actually does influence the heat transfer, and that has a direct implication on cooling. A lot of times the specific gravity can also tell us a lot if there's a contaminant inside too. And then viscosity. Viscosity is a very important characteristic, right? We always know this with lubricating oil, but in this case, it's an important characteristic as well, because it actually tells us the influence of overall heat transfer capabilities and cooling efficiency of the oil has. We're going to take a look at the physical properties according to the ASTM D3487. In this case, we look at type 1 oil and type 2 oils. All right. In this case, there's not going to be a very big difference in the physical properties of these things. But we look at the aniline point, flash, interfacial, and so forth, and various types of limits that are set. And IEEE actually does go forward and help us understand that as well. In this case, electrical properties we want to consider, well, electrical breakdown, also known as the dielectric breakdown of voltage. We're going to run that over 60 hertz. And that indicates the ability to resist any kind of electrical breakdown. It's also very sensitive to water and other types of contaminants. We look at the dielectric breakdown in terms of voltage impulse conditions, and this can happen maybe due to a lightning strike or power surge or so forth like that. We want to make sure that the oil continues to protect as it needs to. And then we'll look at the dissipation factor. Let's also consider the power factor. In this case, we're going to measure the dielectric loss, and any low values indicate perhaps a low dielectric loss in soluble contaminants. That's good to detect, obviously, power loss when insulating liquid is subject to, say, an AC field. And then finally, the gassing tendency. Now, this measures the rate of absorption and desorption of hydrogen. We're also going to take a look at all the types of absorbed gases down the line as well. Here's a table for the electrical properties that we're going to take a look at. The dielectric breakdown, very important, obviously, characteristic here. Once again, we're not seeing a big difference in the properties between type 1 and type 2 necessarily, but we're also going to take a look at the gassing tendencies as well as the dissipation factor here. And here's what the typical properties that we're going to want to look at. Now, in this case, the chemical properties we're going to explore, first and foremost, is oxidation stability. Well, basically, that's going to tell us a lot about acid formation, actually sludge formation as well. And in this case, we're going to want to keep an eye on that, obviously, because that's going to have a direct implication on the overall life of our oil and even our componentry too. We can actually start investigating the additives that are used to inhibit oxidation. What is the oxidation inhibitor content? Those are obviously used to slow down the formation of acids as they build up in a system due to stressing, be it chemical, electrical, or mechanical stressing. We also want to keep an eye on sulfur, corrosive sulfur. And that indicates, we can actually test for the indication of the absence of elemental sulfur or presence thereof. And that helps us understand any kind of thermal instability that might be having and have a direct implication on overall componentry too. And then water content. Water is not necessarily a thing we want in our insulating oil at all. Okay, that's not good. There's several reasons why. It definitely brings about shortages, and it can facilitate oxidation and acid generation. So we definitely want to have a low level of water for sure. We've got to keep an eye on it. And then the other thing too is the acid number. The total acid number, a content necessary to minimize any kind of electrical conduction and even metal corrosion. Once again, as acid builds up, we know that it's going to break oil down, form big polymers that create the sludge in the deposits. And then the furic acid compounds. This happens when you have a cellulosic material break down over a period of time. And that can be in the form of different types of insulating lining paper and so forth, and even wood componentry that can be found with it. And then finally, the PCBs, PCB content. There's plenty of regulations surrounding those. Now, if you know that you have an oil that does contain PCBs, you have to have it appropriately labeled, and you cannot dispose of it, obviously dump it on the ground. You shouldn't dump oil on the ground anyway, but you got to be really careful with the PCBs if you know it's in there. If you suspect it's in there and you haven't tested it yet, once again, we're going to look to see if it is in there. We're going to assume that it is in there and then until otherwise. So it's always important there. In terms of some of the chemical properties that we're going to investigate, well, here's some typical properties that we're going to take a close look at. Now, what's interesting here is we do see a difference between type 1 and type 2 oil. Now, the IEEE doesn't indicate any kind of chemical properties for oxidation stability, oxidation inhibitor content, or oxidation stability in terms of sludge acid testing, right? Or even the corrosive sulfur content. But we do go into things like water, total acid number, furic compounds, and even the PCB content. Here's where the differences lie right there between type 1 and type 2. Now we're going to look at the dissolved gas. And this is really important too. This electrical insulation materials, they decompose. And as they do decompose, they actually do generate gas. And you can actually start understanding what those gases are. And they actually do become dissolved in the oil. But we can test for that. That's indicative of some fault responses, and we can get on top of it way before it turns into a catastrophe. We can actually start understanding the rate of change of this gas generation, even the concentrations over a period of time. We can apply some kinetics and do some linear regressions to try to understand exactly where it's going and how quickly. And the gases we look at, everything from hydrogen, oxygen, nitrogen, carbon monoxide, carbon dioxide, those things are typically indicative of decomposition. Methane, ethene, ethylene, acetylene. Definitely don't want to have those things in there. They can be highly flammable. Now, we are going to take a look at some of the dissolved gas analysis a little bit deeper here. The various faults that are understood, concentrations of hydrogen and methane, as well as ethylene and methylene, that could indicate that there's overheating going on. Hydrogen and methane and ethylene, well, that could indicate that there's low energy electrical discharges or corona effect. And then if you have elevated carbon monoxide or carbon dioxide, that may indicate that there's an overheating of the cellulosic materials, and that's what's breaking it down. We do have that IEEE Standard 57 guide, and that's an interpretation of these gases and what it actually represents. Those gas signatures corresponding to 4 types of faults with key gases, for instance, overheating cellulose and partial discharge and so forth, even with hydrogen and what have you. It's going to give us a good indication of actually what's going on. But also, obviously, the diagnostics, where we're going to check the connections and the leaks, and it's going to help us understand a little bit deeper. A lot of times we can actually use a borescope to take a look inside too. It's going to let us understand if we need to do some oil filtration. It's going to let us understand if we actually have to regenerate a sweetening oil or even reclaim or dispose of it. Now here's a case study. We did a little analysis years ago, pre-trip and post-trip. Not actually taking a journey, but actually tripping the particular circuit. We used the dissolved gas analysis here. There's 3 months in between these events. Now there's some high energy arcing with the power flow through a possible carbonization metal fusion. They utilize what's called the Duval triangle method for interpretation. I won't go into too much of that today at all. That's for a different time, different webinar. But we do take a look at the pre-trip and the post-trip. You can actually see the generation of gases was significant over this period of time, a very short period of time. One thing in particular, though, if you take a look over a longer period of time, you really do see some serious indication that, oh my goodness, there's a lot of gas being generated. Something should have done a long time ago, right? It's not necessarily the case. In this particular scenario, we did take a look at over a period of several years. Actually, these particular devices are designed to run to failure. That's not necessarily the case for many systems, right? But in this case, that's exactly what it is. Be that as it may, it's not necessarily the appropriate cost analysis model I'd choose. However, it's the way this particular application is done and accepted, and the maintenance team is always on call, ready at their will to correct the situation once it does fail. Now, there's various techniques in taking a proper transformer oil sample. Okay, we won't go into a lot of detail on that because it's 5 critical steps. Needless to say is that we always want to make sure we properly label a sample. We've got to identify it and put in the proper information for the diagnostic team to be able to understand what it is you send in. So we want to sample, say, and do it appropriately. We also want to sample every 6 months at least. This is going to give us any kind of abnormal situations that could be present. If there's any PCBs in the fluid, it's got to be identified. It's got to be labeled. It's really important to do that. If you think there might be and you hadn't tested yet, you might assume there is, but you don't know for sure, put down that it is. It's better safer than sorry. PCBs are nothing to mess with. It's always something to show a lot of respect for, so definitely consider that. You get a test back and it says there's no PCBs in it, it's all well and good. Now, as far as sampling goes, there's some detailed instructions on the 923. Gives you some good practices for sampling electrical insulating liquids. Obviously, every 6 months is done, right? Identifying the fluid always says that. But we also want to make sure we comply with our safety standards, both our internal practices for our company, but also the OSHA safety protocols as well, especially if they have PCBs in there. And then finally, procedural steps. This goes into a lot of detail. One thing is we want to make sure that there's never any air trapped in our sample. We also want to make sure that we have a consistent sampling process. So we're very reproducible. Okay, when we think about the overall mission, the vision, and the goal of what we do here at SGS, is to provide data that's precise and accurate, repeatable, and reproducible. Well, here we want to have consistent sampling that's repeatable and reproducible as well. Repeatable, same technicians doing the same process every time. Reproducible, you have different technicians doing the same sampling procedure every time, right? We want to make sure that the bottle sample is appropriate, and we're going to use a syringe methodology for the most part too. And summing up, we want to make sure that we understood the transformer oil testing parameters, how key it is to the adequate testing of analysis, a lot of different tests that we're going to perform in these things that are routine and also not routine, and we can actually carry these things out, give a great indication of the overall longevity and reliability entitlement of these important assets. Next, the consistent oil quality is dependent upon the parameters analyzed. It's very important that we consider that. And also, definitely getting a copy of the IEEE Standard 62 and even the D3487 for dissolved gas analysis. Bring you a little bit more up to speed on it. It's something that we actually cherish dearly in the laboratories here. And maintaining oil installation quality requires a preventive maintenance program. So here at Analysis, well, we go one step further because beyond preventing failure, we're going to have to help predict any potential problems, and then therefore you can rectify that going forward in the future. You don't have to worry about a catastrophe setting in. That'd be an important consideration. This is going to help establish an overall reliability entitlement in terms of how it's going to fit with your reliability-centered maintenance approach. You're going to be really proactive with this. We don't want to make the same mistakes twice. And then obviously routine sampling with good practices, good sampling practices recommended. Once again, at least a minimum every 6 months. It'll keep things, you will not regret it, I guarantee you. That's all we have for today, folks. Thank you very much. Feel free to ask as many questions as you want. And if we run out of time for the question period, definitely let me know by contacting me directly. You can always give me a call as well. Look forward to hearing from you. Thanks.
Thank you very much, Mike. We have several participants here in the session, and if you have any questions, please you can share them here in the chat, and I'll be glad then to pass those on to Mike, and we can cover those as well as we can. Otherwise, please you can always communicate directly with Mike by sending email, and he'll be sure to forward your answers. Any questions for Mike at this time? I have a question for you, Mike.
Okay.
the conductivity and resistivity. Could you comment on that type of measurements and how relevant they can be? They're relevant for transformer oils, and how that may compare to, say, what maybe in other similar type of fluids, let's say turbine oils, which are much higher conductivity and resistivity. Any advice on that?
Well, they are too. A lot of times folks think that conductivity and resistivity are just reciprocal properties of how something's going to be dealing with electron flow. And actually, they're not necessarily reciprocals. There is a difference between if something's more conductive, that means it's less resistant, there's less resistance, or vice versa, where it says if it's more resistance, less conductive. It's not necessarily always the case. So but really what we look at is the dielectric constant, not only and the dielectric constant is going to be the insulating quality, which is really something that also comes aligned not so much with resistivity per se, but it's really the ability to insulate and not allow so much electron transfer from one molecule to another, if you will. So that's a huge thing. Now, that's a very important characteristic for a couple of reasons. First of all, in a transformer, because this fluid is really acting to make sure that we don't have any kind of conductivity between parts and so forth. So therefore, it's stopping that. But one thing a lot of folks never consider is that corrosion requires electricity. It requires an electron transfer, I should say, as does many types of chemical reactions. And so one of the reasons why mineralized water does such a great job at promoting corrosion is that it allows a nice working media for the electron transfers to occur. And so therefore you can have an anticatactonic relationship. One of the bigger reasons why conductivity, resistivity, but more so dielectric constants, important features for oils to have into consideration is because you have what's called galvanic corrosion. And now we know definitely that a lot of systems do have dissimilar metals. So if you have an anionic type metal coupled up next to a cationic metal, be it, let's say, a white metal to a yellow metal being copper-laden alloy, and a white metal maybe being a zinc-laden alloy, one's cationic, the other's anionic, you're definitely going to have electrical potential that ensues. And if you put something that's got a low dielectric constant in there, it starts performing like electrolyte solution, which allows the transfer, and you definitely get galvanic corrosion. But it's also, so now we're looking at three different things. We're looking at a media that is promoting electrical transfer, which is what you don't want in a transformer per se. You're getting a second thing, which is an increase in the oxidation potential of all these species because of the ability for it to be able to react. And the third thing is that you're also getting an increase in corrosivity through galvanic corrosion, through two dissimilar metals acting like a battery of sorts. So yeah, that's a really, dielectric constant is really what we test for. You can test for conductivity and resistivity, but the test method for dielectric constant is really the approved test methodology. When we get into things like conductivity and resistivity, it gets a little dicey. It's almost like trying to do the viscosity of grease. You can do it, but it gets kind of weird with the numbers at some point. That's why we just stick to dielectric constant.
Great, thank you so much. There's another question here from Joaquin Windsor. Is the presence of PCBs in the transformer detrimental to the use of a vacuum dehydration unit to purify the oil?
Well, yeah, and actually I would say yes. And the reason being is that PCBs are nasty carcinogens. They hurt you. And anytime you do a purification using vacuum dehydration, although let's say we take all the proper precautions in terms of our PC, in terms of our personal protective equipment and what have you, you still want to make sure that you don't come in contact both within the liquid phase as well as the vapor phase, which means that you really have to pay attention to not only making sure you wear gloves and all that other stuff, but also protective eyewear. and inhalation too, because if these things become airborne and you are dealing with some exposed stuff, that could be a bit of a problem. So it'd be a huge consideration. I'd really treat I'd treat transformer oils with, if it does contain PCBs, with the utmost care and consideration, for sure. And especially if I'm going to be doing things like conditioning with a form of vacuum dehydration unit to, like I said, take out all the contaminants and make it clean again. So you definitely want to make sure, for sure.
Great. What another question here related to this? What options are available for PCB dechlorination?
Huh? I have no idea. I have no idea. I don't know. I could look into that though. I tell you what, and that was from Ben. Ben,
Yes.
send me over an email, michael.holloway@SGS. Remind me, and I'll do some research for you and get on it. Because I'd be interested in that myself. I want to answer your question, but I just can't do it right now. I don't know it.
Very good. Excellent. Any other questions?
Let's see.
Oh, here we have how important is a nitrogen blanket in the transformer?
Oh, that's a great one. You know, it's really important. In fact, I'm going to go as far as to say nitrogen, dry nitrogen is a very important aspect, but there's something else that happens. I've actually done this quite a bit in other systems like hydraulics and even gearboxes, where I've used dry nitrogen to blanket the reservoir. And if you got the money, it's a little bit more expensive, use dry argon. The reason being, it's heavier. Okay, it will actually stay down. Whereas nitrogen, obviously, we breathe, 80% nitrogen right now. It's going to come back out, but argon will stay better into the sump. So actually, something like that would actually perform a little better, provided it's dry. Now, a lot of times, you got to be really careful, because when you go and specify the gas, definitely make sure that they provide a C of A, to make sure that the gas you're buying doesn't contain any form of any kind of contaminant, especially water. And it does happen from time to time. If you buy nitrogen on the cheap, there's going to be a bit of water in there, and that's definitely not going to. You don't want to do that. So nitrogen's a great idea, but also if you got a little bit of money and you really want to make sure you have a really protected system, something like argon's even better, because it forms a nice heavier gas blanket, and you can get it really dry as well.
Great. Excellent. I think at the moment we don't have any further questions. Let me see. I'm refreshing, see if I catch anything else. And I think that brings us to the end of the presentation. Once again, good to speak with you again, Mike. And
Excellent. If you guys need anything else out there, please feel free to give me a shout. Email michael.holloway@sgs.com. Love to hear from you. Love to be able to help you out for sure.
Great. Thank you, everyone, for your attention, and enjoy the rest of the conference.
Great. Thank you.
Yeah, take care. Bye.
Bye now.